For topic 3, we're going to look at calculating present value with compound interest, okay? Now, I mentioned something very important back in section 8.3 where we were calculating present value for simple interest, and the same thing applies here. When you're calculating present value, whether compound interest or simple interest, you always round up for P, always, okay? So if mathematically you should round up, great, keep rounding up. If mathematically you should round down, round up anyway, okay? The reason for that is we have a goal, A, we need to figure out the future value, or we need to figure out the present value so that we achieve a very specific future value. So we have to at least achieve that future value, if not more, okay? So we always have to round up to guarantee that we reach our future value, because even if we're a fraction of a cent off, we didn't reach our future value, okay? So always round up for P. And then the second thing that I've been mentioning frequently, especially for those of you in the online class, start your own formula sheet. If I have you face to face, I'll print off a formula sheet and give it to you. But if you're in an online class and you don't have printing capabilities, you need to start making your own formula sheet, because what you don't want to have to do is be flipping back and forth frantically through your notes to find a formula that you need. So if you just keep them all on one sheet, it's going to be very, very helpful to you. So when you're calculating present value with compound interest, the formula is P equals A divided by 1 plus R over N raised to the N times T power. And the variables mean the same thing. So A is future value. P is present value or principal. R is the interest rate. T is time. And N is the compounding period. And the compounding period just represents the number of times interest is going to be calculated per year. Okay? So let's do an example or two. Okay? We have two examples here. So for example 4, it says answer each problem. So basically, find each present value. All right? And the questions don't specifically say necessarily find the present value. A lot of times the wording will say something like how much should be invested today. And that's kind of a good indicator that you're doing a present value problem, because you'll know how much you need down the road. You don't know how much you need today. So how much would I invest today is a good indicator that you're finding a P equals problem. All right, so it says how much money should be deposited today in an account that earns 4.5% compounded weekly so that it will accumulate to, that's the future value. So we want $25,000 down the road. How far down the road? 18 years. Okay. So A is $25,000. That's our future goal. We know that in 18 years, we're going to need $25,000. R is our interest rate, and it is 4.5%. So for us, 0.045. T is 18. And then N is the number of compounding periods a year. And since interest is going to be calculated or compounded weekly, we would want 52, because there are 52 weeks in a year. So let's fill in the formula. So P equals A, which is $25,000, divided by parentheses 1 plus R, which is 0.045 over N, which is 52, raised to the N times T power. So raised to the 52 times 18 power. And I would certainly expect you to use a calculator here, okay? Be really careful with these formulas. You need to find a way to type these into some kind of calculator all at once. You don't want to piece these formulas together, because you could end up getting round off error, which would make your answers wrong, okay? You would get values that were not accurate enough, okay? So make sure you know how to type these into a calculator all at once. Okay, as far as showing work is concerned, this is great. Show me the formula filled in and then use the calculator to get the final answer. All right, so let's go to the calculator. Whoops, I started it and didn't finish it. All right, so what I'm going to do is I'm going to get my calculator to do that fraction template. So I would go alpha y equals and just choose the first option. My numerator is A, which is $25,000. That's how much money I need down the road. My denominator, I'm going to start parentheses and then go 1 plus R, which is 0.045, divided by 52, which is N. And then I'm going to raise that to the 52 times 18 power and then hit enter. And we get $11,125. And remember, even if you don't round mathematically up, you round up. But in this case, mathematically, we would round up. So we want to say $11,125.35. Okay? So let's go back to the worksheet. We have $11,125.35. So this is how much you would have to invest today in order to reach your goal of at least $25,000 in 18 years. Okay, so there you have it. That is finding present value. Let's do another example. So part B says, how much should you invest today? Again, that wording, how much should I deposit today? How much should I invest today? Tells you you're finding a P, okay? You're finding P in some kind of situation, all right? So how much should you invest in today in an account that pays 5% compounded daily using the banker's rule so that it will accumulate to $50,000 in 25 years? There's a little typo there. That should say in, not is, okay? So let's get some pieces here. We know what A is. A is $50,000. Okay. We know what R is. R is 5%, so 0.05. Now we know what T is. T is 25 because we want $50,000 in 25 years. But what is N? Well, I told you at the beginning of this section, when you're talking about the compounding period, be very careful with N because N, when you're talking about daily, can be two different things. So if we scroll all the way back up to the top of this, we have, if interest is compounded, we were kind of talking about the compounding period. And notice I have daily in here twice. So if the directions say that interest is compounded daily, just plain old daily, N is going to be 365. However, if interest is compounded daily with the banker's rule, this is only 360 times per year. So N is going to be 360. So let's go down to our problem right here. Okay, so how much should you invest today in an account that pays 5% compounded daily, banker's rule? So in this case, N is 360. Okay, if we weren't using the banker's rule, we would have used 365. Okay, so let's fill in the formula. So we get P equals 50,000 divided by 1 plus R, which is 0.05, divided by N, which is 360. And we're going to raise that to the N times T power. So 360 times 25. And we will type this all into a calculator at once. You're not trying to piece things together and round as you go because you'll get crazy answers. We want to type this into the calculator all at once and see what we get. So going back to the calculator, and I do apologize for the flipping back and forth. I don't have a great setup for technology, but we get the job done. Okay, so we're going to go alpha y equals and then choose option 1. That gives us the fraction template. For the numerator, we want to type in A, which is $50,000. That's our future goal. For the denominator, we want to start with parentheses. You do need the parentheses here. And then we go 1 plus R, which is 0.05, divided by N, which is 360 with the banker's rule. And then we want to raise that to the N times T power. So 360 times 25. Was it 25? Yeah, 360 times 25, and then just hit enter. And if we want $50,000 in 25 years, we would need to round up, don't forget, $14,326. And let's see, we have 0.483. The 8 is what we're interested in. To the right, we have a 3, which would ordinarily tell us to round down, but don't forget with P, we round up no matter what. So even though mathematically we would round this to 48 cents, we're going to round up to 49 cents, okay? So we get $14,326.49 rounding up. So back to the worksheet, and we get 14,326.49. And that is how much you would have to invest today in an account that pays 5% interest compounded daily with the banker's rule so that you could in 25 years have $50,000. If you only invested the 0.48, you wouldn't meet your goal. And let me kind of show you what we mean by that, okay? So for fun, let's figure out what A is if we didn't round up. So remember the formula for future value with compound interest is P. So 14,326.48. Remember, if we didn't round up, times 1 plus 0.05 divided by 360 raised to the 360 times 25. We'll go to the calculator with that. And remember, we have to get at least $50,000. If we don't get $50,000, even by a fraction of the cent, we didn't meet our goal. So this is going to show you why we have to round up. Okay, so we have $14,326. And remember, let's pretend we didn't round up and we just typed in 48 times 1 plus 0.05 divided by 360 raised to the 360 times 25. And you can see here we're short by less than 2 pennies, but we still haven't officially met our goal, okay? So if we don't round up, we're going to be short. Like I said, it's less than 2 full pennies, but we still haven't met that goal, which we have to at least have $50,000. Now look what happens if I take that same formula and instead of doing the 48, I do the 49. So by rounding up, there we met our goal by a little bit more than 2 cents, okay? So this is why you have to round up with P. If you don't round up, you don't meet your goal. Again, it may only be a penny or two, but you still haven't met your goal, okay? So you have to at least meet your future value goal of, in this case, $50,000. So in order to achieve that, we had to round up to the next cent. So 49, not 48 here, all right? Now let's go back. I think that's it for this topic. The next video, yes, one more video for this section, and it's on something kind of wild and wacky called effective annual yield, and then that'll wrap up section 8.4.